Welcome to aminacademy.com. In Strength of Material, let us discuss about some introduction of strength of materials. Strength of materials, also called mechanics of materials, is subject with deals with the behavior of solid objects to stress and strain. Suppose any material is subjected to an axial load, that means compression or tension. So because of this load, some behavioral change is happen in the solid within the limit of the load. So it is called strength of that material, means how much strength it can withstand for particular load. So we'll study about this, is called a strength of material. The complete theory began with a consideration of the behavior of one and two-dimensional members of structure whose state of stress can be approximated as two-dimensional, and was then generalized to three dimensions to develop a more complete theory of the elastic and plastic behavior of materials. An important founding pioneer in mechanics of material was goes to Stephen Timoshenko. Here we'll discuss about the definitions. In mechanics of materials, the strength of material is its ability to withstand an applied load without failure or plastic deformation. Means here that without failure, how much the load can withstand by a material is studied about in this subject. The stresses acting on the material cause deformation of the material in various manner, including breaking them completely. That is, deformation of the material is called strain when those deformation too are placed on a unit basis. The applied loads may be an axial, that is tensile or compressive, or rotational, that is shear stress. Here consider a small piece of material, suppose it's in a round space. Here suppose we are applying a load of pulling. Here up to some extent of load it can withstand that load. After increasing the load, so some small changes in the material which is caused by the axial load. So due to that axial load, a force is acting perpendicular to that load. Here now stress means now we can define the stress is acting on the material cause deformation of the material in various manners, including breaking them completely. After increasing continuously the load of pulling, so it causes to break. Now suppose here due to application of that load there is small increase in the length of that load in the particular limit of deformation, then we can say, then first we can say stress is force, that is force of pulling applied by the cross-sectional area of the material. Strain is due to that force some changes in length is happen, that is change in length by original length. Here for stress unit may be Newton per mm square, Newton per centimeter square. Like here for strain no unit, since it is the ratio of the same units, means length over length. Once the state of stress and strain within the member is known, then strength, that is load carrying capacity of the member is its deformation stiffness quality and its stability ability to maintain its original configuration can be calculated. Material strength refers to the point on the engineering stress strain curves, that is yield stress, beyond which the material experiences deformation that will not be completely reversed upon removal of the loading and is a result of member will have a permanent deflection. Suppose some material is there, if you apply a continuous load, continuously it's increasing, the deformation of the material happen. After releasing the load, that deformation will not get back. That means that material will not come to the original shape. That is, it's called a plastic limits. It's beyond the plastic limit, it won't return to the original shape. The ultimate strength of the material refers to the maximum value of stress reached. That is, the fracture strength is the stress value at the fracture. That is, the last stress value is recorded. Now, further videos will continue about more details about stress and strain and its behavior. We have done. Please subscribe our YouTube channel.